Welcome to this video on cumulative probabilities of a binomial distribution. In this video we'll start looking at the basics behind using the tables, and for some of you we'll look at also using the calculator, although I would always recommend that you're able to do the tables in the exam and that you do use them and you just use your calculator to kind of check your answers afterwards. As over the last few sets of exams, there have been comments from the chief examiner about a lack of working with some of the answers and therefore students not achieving the full marks. So with that to do, let's kind of get straight into talking about it. And if you're not aware, the cumulative probabilities, this is when we look at things like x is less than or equal to 5, or finding probabilities like x is greater than 3, and so on. Now, one thing to remember though with binomial is discrete data. And as such, when we get certain values like this one here, x being greater than 3, we always need to change these into a greater than or equal to, for example, 4. So we always want everything to be less than or equal to or greater than or equal to initially. So let's set up a few examples like that so that you can see. So these are the kind of possible scenarios you're going to get. And with that, sometimes you're going to have to think about the wording. So if I think of this first one, probability where x is greater than 3, that comes from, greater than 3. And then if I look at this second one, less than or equal to 2, this is one that could be like an at most 2, which would mean that you're looking at less than or equal to 2, or, no more than 2. So sentences like that would produce this inequality. At least 8. So at least 8 would be 8 or more. And then, something like less than or fewer than 5 would mean that it doesn't include that 5. So those ones, these kind of rough sentences would give you an idea of what inequality you'd have to set up when you're doing your probabilities. Now let's also look at what we would do from here. So what I said at the start of this is that you always want an equals. So we don't want just the greater than. So this would be probability where x is greater than or equal to 4. Because if it's greater than 3 and it's discrete data, it means that it's 4 and above. So that's what we have. And then if we come to our tables, that will become the probability of, 1 minus the probability that x is less than or equal to 3. So if you want 4 or more, it's the same as 1 take away 3 or less. And this is because my tables are always set up to give me the probabilities where x is less than or equal to that value of x. Looking at this next one, it would just stay the same. It's already in terms of less than or equal to 2. The third one here would become 1 minus the probability that x is less than or equal to 7. Okay, you'll see 8 or more is 7 or less, so 1 minus that. And then this next one here, less than 5, is the same as x is less than or equal to 4. Okay, less than 5 doesn't include 5. We need to make it so it's equals with it. So each one of these, what I'd say is when you approach the question, think the words will give you the inequality, and then from the inequality, whether it's greater than or less than, make sure it has an equals there first. And then once you have it in terms of equals, if it's greater than that, you need 1 minus, and then it's always going to be one number less. If it's already less than, you're golden. And that should help you out now with actually solving the problems. So let's get into a few. First one we're looking at is a straightforward one. We've got a binomial distribution, n is 20 and p is 0.4, and this is what we're trying to find. So for part A, we're looking at probability where x is less than or equal to 5. It's already in the correct form, so it's a matter of looking this up. So I need to find n is 20 and then p is 0.4 within my binomial tables. So you'll find these in the back of your textbook. You can also find them in the formula booklet. Now this is one of the pages within that formula booklet, or the end of your textbook, and you'll see that you've got probabilities along the top. They're going up in kind of 0.05s, so like 5%, 10%, 15%, 20%, and so on, all the way up to 0.5 there. And you can see here we've got n is 12, n is 15, n is 20. This is obviously the one we want, this section of the table. What I'll do now is I'll just zoom in so that we can work out this one and the coming questions. So here we have it, n is 20, and we want p is 0.4. So we're looking at this section here initially. So if I just kind of block that off for you. And then we want x is 5. Here's our 5. So we're looking at this value there. So 0.1256. And that is part A done. Now with part B, we have that x is less than 3. So as I said before, make sure it's equals. So x is less than or equal to 4. And again, then we're just looking at 4 in my table. So looking at where the 4 meets the 0.4. So you have 4 across, and that's 0.4 there. So we've got 0.0510. So nice and easy so far, isn't it? Now, probability where x is greater than 7. So make it equals first. Probability x is greater than or equal to 8. So this is then 1 minus the probability that x is less than or equal to 7. I know some of you are probably thinking, well, I can just jump straight from here to here. And by all means you can. But in my experience, this is where people make a lot of mistakes. Okay, so following this set procedure will help you as we do all these different, binomial, Poisson, and then convert it into normal later on. Okay, so just follow these set procedures until you fully kind of understand what's happening. So here we have 1 minus, and then get rid of that previous one. So when x is 7, so again, we're just going across from 7, you can see here, and down from the 0.4. So 1 minus 0.4159, and then just pop to my calculator, and I get 0.5841. And then finally, when x equals 6, so we can obviously use the formula from how we worked them out in the first video, the last video. But there is another way. So x equals 6 is the same as x is less than or equal to 6 minus the probability that x is less than or equal to 5. Because if you think about it, this is everything below 5 and below. This is everything 6 and below. So take them away and we're just left with 6, aren't we? So that means that I can go across from my 6, and I got my 6 and my 5 there. So that's 0.2500 minus 0.1256. And then it's just a matter of going to my calculator, and I get 0.1244. So there we have our answers, and you can see that, from the tables, it's so much quicker, isn't it? Now, second example here is a more worded one. So we've got a town here, 30% of the residents listen to the local radio, 10 residents are chosen at random. The X represent the number of these 10 residents who listen to the local radio station. So here's my distribution. X is binomial, 10 is my value, and 0.3 there is my probability. And then we also need to comment on any necessary assumptions. So our assumptions are the same as they kind of always are. So there are 2 outcomes. And the 2 outcomes are listen or don't listen, isn't it? Nothing else. Secondly, there are a fixed number of trials, isn't there? And that would be 10. And of course, a fixed probability. And then finally, we should put that actual probability in, shouldn't we? 0.3. And then finally, it's the independent bit. So we need to assume each resident listens independently. Because in cases like this could obviously be not true. So we have to make sure that, that is assumed, that they are listening independently. And that's part A done. It shouldn't be too difficult. Like I said in the previous stuff, it's just, there's always going to be a couple of things that you need to remember and essentially apply them to all of these kind of worded questions, isn't it? The assumptions that you make. Now, part B is find the probability that at least half of these residents listen to the local radio station. So probability, at least half, means it's going to be greater than or equal to, and half of n would be 5. So we're looking at greater than or equal to 5, so that's 1 minus the probability that x is less than or equal to 4. And all I need to do then is look this up in the table. So we've got n equals 10, which is here, and we've got probability is 0.3. So this line we're looking at, and you can see 4 is this one here, 0.8497. So 0.8497. And then in my calculator, I get 0.1503. Nice and hopefully not too difficult. Now, part C is obviously where it gets a little bit harder. I'm just going to make a little bit of room. So with part C, we can say that probability of x is greater than or equal to s. And we want that to be less than 0.01. Now, when I've got greater than, I need to do 1 minus. So this is x is less than or equal to, and remember it's always one value less, so s minus 1. So a bit of rearranging, and we get probability that x is less than or equal to s minus 1 on the right. And taking my 0.01 away, so it's on the left, we get 0.99. So now we want the value where we're going above 0.99. So to make my life easier, I've just and make it easy to show you, just cut out this section here from my tables. So we've got this, and we're looking for greater than 0.99. So 9899. So this is where we're looking, yeah. So I always like to make sure I get either side of the value I want. Okay, so I always want to do that first to make sure I'm either side of it. Now, the one I want is clearly greater than, isn't it? Greater than the 0.99, so it's got to be the 7. Yeah? So this is going to be probability that x is less than or equal to 7. which is where it helps me out, because now I can see that s minus 1 is equal to 7, so this s must equal 8. And that's the scenario I'm in. And I just want to double check, all the way around now. So when s equals 8, if I go right from the beginning, and I'll do this in a different color. So we go probability x is greater than or equal to 8 is 1 minus the probability that x is less than or equal to 7, which is 1 minus 0.9984, which is 0.0016. And that's clearly then we can see which is, so 0.0016 is definitely still less than that 0.01. Okay, if I'd taken this value, I've got 1 minus 9894, and that would give me 0.0106, which is just bigger than what we wanted. Okay, hopefully that was easy enough for you guys to follow. Not the only way to kind of set it out, but that is kind of what I am looking at. I think that's what makes the kind of most sense here. Okay, now we're going to look at this question with our calculator. So to do that, first we need to go into menu, and then we need to look at distribution, which is number 7, and we have these options. So first 3 are normal, which we don't need, and we've got number 4, which is binomial PD, and then scrolling down, number 1, binomial CD. This is the one we're going to be focusing on initially, cumulative distribution. So I want to click number 1. I've got 2 options here, list or variable. List is if I want to get more than one answer. Variable is if I want to just look at one answer. This is where we're going to be focusing, so number 2. Now for question 1 part A, the value of x that we're looking for is going to be less than or equal to 1. So I'm going to put 1 in for my x, press equals. N is 12. So put that in, and my probability is 0.2. So 0.2, press equals. Now when I press equals again, I get my answer of 0.2749 when I round to 4 decimal places, which you can see is exactly what we had for part A when we used the tables. Now if I want to again come back to that, so just click menu, click 7 again, scroll down and kind of go back into it. For part B, we wanted greater than 3, which was greater than or equal to 4, which is 1 minus less than or equal to 3. So that's what we're doing here. So we want 1 minus less than or equal to 3. So we want to change x into 3. Everything else will stay the same. So I can press equals and again, and I get this 0.7946 if I round that to 4 decimal places. Now I want to do 1 minus that, and if I just try clicking, say 1 minus, you can see nothing changes in my calculator. So what I want to do is I want to store this. So I'm just going to click store, and then you want to pick one of these letters. You use X or Y as well, but I'm just going to pick A. So you can see there, stored to A. Now, if I come out of this, so menu and 1, you'll see if I just click on alpha A, you can see it is that value there, it was stored. So all I need to do is 1 minus A, so alpha A, that. Press equals, and I get 0.2054, which is exactly what we had as our answer to part B. Now, part C, we just want x equals 4. Now, if I want an x equals something and not a less than or equal to, I want to use this binomial PD. So that's the option for that. Again, I'm going to use variable. So this time I'm looking at x equals 4. I know that n is 12 and my probability is 0.2. Press an equals here and then I get 0.1329, which you'll see is just slightly different to our answer, which was 1328. But don't forget, we use two values from the tables, which are rounded to 4 decimal places, and then they subtracted, whereas this one is given it's the exact answer using the formula which we did in the previous video. And if you did use the formula, you would get this answer. So we've got 0.1329, which is a slightly more accurate answer there. Now, looking at this question, you may have noticed that this value for P is not in our tables. Here's the section from the tables, and you can see that we've got from 0.05 all the way up to 0.5, which obviously gives us a little bit of an issue when we've got 0.7. So if I want to use the tables, I need to find a workaround. And the workaround is simple. If I think of the opposite of that, so 1 minus that 0.7, I get 0.3. And 0.3 is in the tables. So what I'm looking for is a new distribution. So instead of x, what I would say is y is binomial, and we're looking at 15 and 0.3 as that probability. And what that means is that y is going to be opposite to my x values. Now let's just get the table up and go from there. So with A, we've got the probability of x is less than or equal to 3. Now this is the harder part, working out what's happening with y. So the easiest way for me to kind of explain it is to kind of visually do it. So if you think of, I've got up to 15. So just to kind of visualize it, so we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, if I think of initially for x, I'm looking at these values, weren't I? Between less than or equal to 3 was 3, 2, 1, 0. So there's 4 values. And that is what my x was. Now, if I think of this in terms of I'm going to write this in red, at the other end, so in y, I'm looking at this end instead. Okay, so this would be my y, which is the complete opposite. So instead of the first 4 values, I want the last 4 values. Okay, so you can see 1, 2, 3, 4, 1, 2, 3, 4. So the equivalent value for y, so when x is less than or equal to 3, y is greater than or equal to 12. Okay, and that's what's important there. I'm having the same number of values, but from the other end. So this is 1 minus the probability that y is less than or equal to 11. And then I go to my tables here. You can see it's very, very small, isn't it? So 1 minus 0.9999, and this would be 0.0001, which is actually a rounded off value. I probably haven't picked the best numbers to do here, but we'll look at the other ones in a moment. But what we've got here is if I do this in the calculator, and I'll show you this value, doing it in the calculator, and I'll show you using y in the calculator, and you'll see that both answers are the same. So here you can see I've got into the binomial CD ready, and what we're going to do first is our x is less than or equal to 3. So x is less than or equal to 3, n is 15, and my probability is 0.7. And it's these kind of probabilities where the calculator does make a huge benefit to you, or is a huge benefit to you. So here you can see we've got 0.00004 zeros, 9165869. Okay, and I can store that if I want to, just as I'll store it in there F in case we want to check it up later. But you can see that the answer we got from our tables was 0.0001 because it was rounded to 4 decimal places, which is what this would be to 4 decimal places. So that's using the 0.7 and in the calculator. Now, if I go back into here, this time what I'm going to do is I'm going to switch it up. So when we used y, we used greater than or equal to 12, which was 1 minus less than or equal to 11. So let's put 11 in here and change this probability to 0.3. Okay, hit my equals and I get my value here. We're going to store that as A, and then I want to come out of this menu and 1 minus that, because that's what we were doing, wasn't it? And here you can see I've got exactly the same answer. So there it is, 0.409165, and if I bring up alpha F is where I stored it, again 0.409165, etc. So you can see that this method that I'm showing you here is another way of approaching these questions. For the rest of this question, I'm going to be showing you how to do it in terms of the tables and using what I've got here, which is my binomial in terms of y. But alongside it, I will put the answers from the calculator. So if you're doing that, you can see those answers, which will be slightly more accurate in places. So part B is x is greater than or equal to 5. So here, if I think x is greater than or equal to 5, this is what we're looking at, aren't we? X is greater than or equal to 5. So we've already got 4, and I missed out the 0, 5 values that we're not looking at. Okay, so that's what I want to do in terms of y. So if in terms of y, I want to essentially skip my first 1, 2, 3, 4, 5 values, 2, 3, 4, 5 values, so less than or equal to 10 here. So that is therefore my y. So this is the probability that y is less than or equal to 10, which is quite nice because that's straight in my tables there, and we get 0.9993. And then in the calculator, we got x greater than or equal to 5, which is obviously 1 minus x is less than or equal to 4, which I'll just actually skip to the answer, but it's 0.9993 as we had, and just to show you the extra points, we had like 2, 7, 7, and so on, 6, 5, 9 in total. Okay, but just to 4 decimal places, you can see there that it is the same as what we had. Part C, probability where x is greater than 7 means we're looking at probability x is greater than or equal to 8. Now in terms of my y values, so just popping my numbers up again, and of course putting that 0, forgot about that. So greater than or equal to 8, that's these values here. So you can see we've got 1, 2, 3, 4, 5, 6, 7, 8 values in total. So that is my x. So going in terms of my y, I want 8 values. 1, 2, 3, 4, 5, 6, 7, 8. So here is my y. In this case, my y is less than or equal to 7. I'm just popping that underneath. Y is less than or equal to 7, which in my tables is here, so 0.9500 there to the 4 decimal places. Now in my calculator, of course, I can do x is greater than 7, which is, as we had already said, greater than or equal to 8, which is 1 minus x being less than or equal to 7. And this is 1 minus 0.0500, which, as you guessed it, is 0.9500 when I do it to 4 decimal places. The exact answer it comes up with is 0.949987 and so on, which when you round to 4 decimal places, rounds these up. Finally, part D here is that x is greater than or equal to 4 but less than 9. Remember, we need these equal, so we've got less than or equal to 4, that's unchanged. Sorry, greater than or equal to 4 is unchanged, but less than or equal to 8 is what we're looking at. Okay, now if I bring up the numbers again, this time we've got from 4 to 8, and inclusive of these numbers. That's my x. And what I want to do is just think about exactly kind of what's happening. Now I could think of like these values, just finding this in the right place, or I could think about what I'm doing with this, which might be a little bit easier. So let's do the latter, because what this means is that x is less than or equal to 8 minus the probability that x is less than or equal to 3, because that will leave me with 4 to 8 then. So doing it that way will make this probably seem a little bit easier. So for my x's, I'm basically looking at this one and this one, aren't I? So it's one minus the other one, which means when I'm turning in terms of y, so we've got 1, 2, 3, 4 here. 1, 2, 3, 4. So we've got greater than or equal to 12 there. And then our next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going from the greater than or equal to 7 here. So in terms of my y, I want greater than or equal to 7 minus y is greater than or equal to 12, which at the moment is quite confusing. So actually, I think, I could proceed from here, but I think actually it would be easy to go back to the original way I was going to look at this. So the original way here was between 4 and 8, wasn't it, inclusive? So I'm just going to rub these ones out. I'm going to rub this one out as well. That's what we're going to need for our calculator in a moment. But for now, we don't need it. So changing to my red pen, you can see here we've got 1, 2, 3, 4 numbers. 1, 2, 3, 4 numbers. So we're going to start at this 11 here. And it contains 1, 2, 3, 4, 5 numbers. So 3, 4, 5. So this is what I'm doing with in terms of y. Okay, the black was in terms of x. Again, if you looked at where the 8 was, it's 9 numbers there. So 9 numbers from this side gives me the 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what we're looking at. We want between 7 and 11 inclusive. So for my y, and again, I'll pop this one in red so you can see it here, but we want between 7 and 11 inclusive of those. So that's going to be the probability that, apologies, y is less than or equal to 11 minus the probability that y is less than or equal to 6. Okay, remember that if we went from 11 to 7, 11 and below gives us all of these, 6 and below we'll get rid of, leaving us between 11 and 7. Now I can go ahead and look up in my tables. So 11 is here and 6 is there. So we get 0.9999 minus 0.8689. And that gives me 0.131. Now, in terms of the calculator, remember that this was, if I do it in full again, just writing down that first bit. So this was going to be the probability that x is less than or equal to 8 minus the probability that x is less than or equal to 3. And then I want to go to my calculator and get these two values. And for this then we get 0.13105, which in this case is 1311 to 4 decimal places. So you can see it's just slightly more accurate than this answer, and this is just because we're using obviously two numbers that are already rounded to 4 decimal places, whereas in this question this one had more decimal places. I just cut it short there, and of course this one carried on there. Both of these had additional numbers, so it's just slightly more accurate there. Okay, but hopefully that question wasn't too bad. And like I said, it is flipping this to the 0.3 is possible. You just have to start working from the other end of your numbers rather than the beginning end. Okay, and of course, if you've got the Casio calculator, the 991 or the 570 of the newer ClassWiz ones, then of course you have your distributions within there, which does make this a lot easier. I would still be, if I'm using my calculator, I would be putting this, what I've got in purple here as my working out, and I might mention, from calculator. If I was doing it from the tables, if I didn't have that calculator, I'd use this method, which I've got in black here, on black and red, and you can put from tables. Now this question, my calculator is less useful to me because I don't have an option with Binomial to be able to look up areas or probabilities. It is possible with normal distribution, as you might have seen in S1, but not with Binomial or Pearson, which will be the distribution we do after this, these Binomial ones. So I do need to use the tables for this. So let's have a look at the first one. We've got that value of k such that this exists. So p, where x is less than or equal to k, is less than 0.05. So this is quite nice and easy because it's going to be straight from the tables. Okay, I'll just pop this one in here. Can't make it too big, but we're looking at our values now where this exists. So less than 0.05. So 0.01, 0.02, so if I just circle kind of these two values here, 13 and 14, you can see that 14 is just going to fall outside of that, 0.054, so 13 is going to be our value. So in this case, therefore, k is going to be equal to 13. And this is because if I look at that, it's going to be 0.0280. Whereas if I looked at, say, the 14, which is next to it, that's 0.0540. And it's always nice to kind of put those two values down, just showing the examiner that you've picked out the two values either side of the one you're looking at, and then you've selected the right one. It also ensures that if something happened and you actually accidentally selected the wrong one, there is something that you could pick up in terms of some working out marks there if you've got the two kind of correct values out. So that's part A. Now part B is slightly different, and that's because it's a greater than. So we're looking at x is greater than r, which is less than 0.01. So what I want to do here is take this in a few steps. So we would want actually greater than or equal to. That's what I'd be thinking of. So that's going to be 1 more than that value of r. But of course, our tables don't give greater than. So this is going to be 1 minus the probability that x is less than or equal to, and then it's going to be 1 minus this value, which of course is back to my r. Now it's important to do these steps as I'm doing here, because if this was a greater than or equal to already at the start, we'd end up with an r minus 1 here. So by doing these steps, you just ensure that you don't make any mistakes. Now a bit of rearranging, if I take this to the right and this to the left, I would get that the probability where x is less than or equal to r is greater than 0.99. Okay, and that's what I'm looking at now in my tables. So we want greater than 0.99. And looking down my tables, we've got 9.8 and 9.9 there. So let's just kind of block these ones off. Okay, so greater than 0.99, well, greater than 0.98 is not going to fall within this greater than 0.99, so it's going to need to be this one, okay, where r is going to be our less than or equal to 28. Or is it? Of course it is. So r here equals 28. And just, kind of like on my side for those values there, you know that your x is less than or equal to 27 gave me that 0.9840, and my x being less than or equal to 28 was my 0.9924. Now, if you think of these values in terms of, what we were looking at here, we wanted greater than 99. So this one is smaller than 0.99, and this one is greater than 0.99, which is why we chose this one. And if I go back to the first ones, we wanted, in this case, less than 0.05, didn't we? And if I look here, this one was less than 0.05, this one was actually greater than 0.05. So it's quite clear which one works, with these. Okay, so that's my A and my B. And then my C, now that I've got the values, will be quite straightforward. So now we could say that this is going to be between 13 and 28. So this is going to be the probability when x is less than or equal to 28 minus the probability when x is less than or equal to 12. Remember that we want 13 to 28, so getting rid of 0 to 12 from my 0 to 28 leaves me 13 to 28. So 28, we know that value is there, and this time we also need 12, which is there. So we get 0.9924 minus 0.0133. And then in my calculator, we get 0.9791. And that is my answer. I should also point out that since all these are to 4 decimal places, your answers should be accurate to 3 decimal places here. Okay, and if I do the calculator version, I should get basically the same. And then from my calculator, we got 0.9791320,493. So you can see there, exactly the same to 4 decimal places there. But you've seen in the past it's not always accurate to 4 decimal places, but it will be to 3 decimal places. These should match up always to 3 decimal places. Now that's the end of this video. Don't forget to subscribe, hit a thumbs up, and comment down below if you want to ask any questions, or you want to comment on the video if there's anything you liked, didn't like, anything you want to see more of as we go forward into this statistics 2 unit. Just let me know in the comments.